Hello and welcome back to Statistics1, section 4.3, some rules of probability. Note that the title, it's like just a little bit, right? Don't panic, right? There's no reason to lock the doors, right? We're just going to do a little bit and then we go home. So some rules of probability. First off is the notation. Look at that. Notation. So probability of an event A is equal to some number between 0 and 1. Right? That's, if it's 0, probability of event happening is 0. And then if it's 1, then event will happen with certainty. And now we have the special addition rule. No coughing. And this one says that probability of A or B is equal to probability of A plus probability of B. Now, this has to be emphasized. If A and B are mutually exclusive. I have to box this together, because if the events are not mutually exclusive, you get to do the little subtraction piece. All right? So let's take a look at the simplest example and then a little bit spicier example. So flip a coin. Flip a coin. Event A, flip heads. Event B, flip tails. We know that the probability of A is a half. Probability of B is a half. So, and you know they're mutually exclusive because you can't flip heads and tails at the same time, because they're on the opposite side of a coin. So flip a coin, we have this, and what is the probability? So probability of A or B in this case would be 1/2 plus 1/2, which is 1. And this makes sense, because when you flip a coin, you're either going to get one or the other. You are certain, right, to get one or the other. Use the language, the English language, to understand this word problem. When you flip the coin, I use the word or. So I'm asking you, what's the probability to flip heads or tails? Well, it has to be 100%, because it's going to be one or the other. There's no third, right, in the game at all. So probability of flipping heads or tails is 100%. Now, more spicier example would be, let's play cards again. Say event A, pick a face. Event B, pick a 7. Right? So these are your choices. Well, what's the probability of A? And keep all of the denominators 52. Don't reduce anything because we have to add later, right? So to pick a face, you have 12 face cards in 52 cards. So probability to pick a face is 12 in 52. Probability to pick 7, which is event B, is 4 out of 52. And no faces are 7s and no 7s are faces. Therefore, they're mutually exclusive. I can say ME check, mutually exclusive. Therefore, to pick a face or a 7 is simply 12 over 52 plus 4 over 52 to be 16 over 52. And now you can reduce right down to 8 over 26, 4 over 13. So probability to pick a face or a 7 is 4 in 13. You can go ahead, use the abacus and get the decimals if you care. What's 4 divided by 13, anyone? It's a number, very good. Next problem. 0.307. Thank you. So about 31% chance to win, right? And 69% to lose in this game. So that was the special addition rule. And then we have the complementation rule. And a complementation rule simply says that the probability of an event is 1 minus the probability of not an event. Remember how when I asked you what it means? That it's going to be 70% chance of rain today? What it means? 30% of no rain today. So it's either rain or no rain, and the difference between them is 1 minus the other. So that's what I said. Please pay attention. It's clearly an A. Look, A. Thank you. Roll a die. Probability to roll a 4 is 1 in 6. Probability to roll not 4, which means roll anything else other than a 4, is going to be 1 minus 1 over 6, which is 5 out of 6. Does this make sense? Well, sure. What are the other options? If 4 is one that kills you and the other ones are the ones that give you money, what are the other options? 1, 2, 3, 5, and 6. 5 of them, right? And we see that the formula gave us exactly that. I have to keep using that example because the book is grim, so I'm just trying to match the... There it is. General addition rule. So for this one, I guess purple. Oh, I forgot to put a box around formula over here. Oh, I'm going to use purple for the box. Orange. We don't need mutually exclusive events. So, any events for any events A and B, formula says probability of A or B is probability of A plus probability of B minus the probability of A and B. Now, in general, this is the formula that confuses people, but we already discussed this. And now we're going to put this in that example. If you remember the example before, we said that event A are red cards. And event B are face cards. So probability to pick a red card, which is probability of event A, is going to be 26 over 52. And probability of B, face cards, is 12 out of 52. Now we also have probability of A and B, and those are the 6 red cards that are both. So these are just red, these are just face, and these are red face cards. So now probability of A or B is going to be 26 over 52 plus 12 over 52 minus 6 over 52 to remove the doubling up to get to the one that we had before, which is 33 over 52. What did I say?
33.
Yeah, it doesn't want to erase it, so it's going to stay 33.
Yeah.
Huh. There we go. Which is what we had in our previous exercise somewhere. Oh, I didn't. We switched to the cards and we looked at it. Now, I'm going to go and look at the deck one more time. Remember, I'm looking for 32 cards. 1, 2, 3, 4, 13, 14, 15, 16, 17, 18, 26, 27, 28, 29, 30, 31, 32. There they are. So, red or face, exactly 32. Why was that subtraction piece there? Because these cards were counted as red and they were counted as faces. So they were counted twice. So if you subtract it once, those 6, you will get the right amount. So that's the part that's important, to subtract the overlap. Subtract the overlap. So the lecture is over. Now I want to go into word problems in the back of the book and take a look at some death or misery, whatever they have over there. Let's see. Twelfth grade smokers. Oil spills, internet access, utilization, student debt, sales tax. What are we going to look at? What are you interested in? Child smokers. All right. We're going back to child smokers. 12 grade smokers. 12th grade. Well, 17, 18, yeah. So, the National Institute on Drug Abuse issued a report monitoring the future, which addressed the issue of drinking, cigarette, and smokeless tobacco use for 8th, 10th, and 12th graders. So 8th, 10th, and 12th. During 1 year, 12,900 12th graders were asked the question, how frequently have you smoked cigarettes during the past 30 days? Based on their responses, we constructed the following percentage distribution for all 12th graders. 73.3% said no cigarettes in last 30 days. 9.8% is some, but less than one. I don't know how you can smoke, whatever. And then 1 through 5, and then 6 through 14, and 15 to 25. 35 or more cigarettes was 0.3%. So all of these are labeled in a book in the what we call distribution table, because it shows the relative frequency at which these smokers are encountered. So someone who smoked between 15 and 25 cigarettes, there will be 2.8% chance to run into someone who smoked that many. So find the probability that within the 30 days, a randomly selected 12th grader, and nowadays smoked. So for part A, so what is the probability that you talk to someone who smoked? Yeah. So we first know that probability of not smoking is 0.733. That was the probability given to us because these never smoked, which means that the probability of a smoker is 1 minus 0.733, which means 0.267. So about a quarter of all of these did smoke. Now, smoke at least 1 cigarette per day. Smoked at least 1 cigarette per day. How much is that? Note the... Yes? Excellent. So, at least 1 cigarette is right here. And all of these, right, if this one had 26 cigarettes percentage, right? To get there faster, or you can just add these 5 numbers on the calculator, whatever it's. So you can use the complementation rule to say, okay, how many smoked less than 1 cigarette? It's this much, and then 1 minus that. Or you can add these 5 and get the same value. Now, I like complementation rule because it's faster, right, for lazy people. So, part B, smoked less than 1 cigarette. So, probability of less than 1 cigarette. And that would be our 0.267 minus 0.098. So that would be our, right, because I am decreasing this. So 7 minus 8 would be a 9. We stole 1 from there, so that's 15, and that's a 6. And we stole 1 from there. So so it's about 17%, about a sixth of all surveyed 12th graders smoked at least 1. And then finally C, probability that they smoked between 6 and 34. Okay, so 6 and 34. So what do we have? Well, 6 to 34, we have to add 5.3. You can't see the numbers. 5.3 plus 2.8 plus 0.7, which is 8.8. Oh, that's percents. You should say 0.088. 0.088. These are percents. We need a decimal between 0 and 1. So be careful. There's a decimal and then there's a percent. So for this question, smoked between 6 and 34 cigarettes. 6 and 34 cigarettes. So adding these three numbers will give us the probability. Now they're mutually exclusive, so we just add them. We don't have to worry about subtracting anything, because if you smoked 26, you definitely didn't smoke 41, right? Because you smoked 26, you didn't smoke 41. So they are mutually exclusive. These ranges are mutually exclusive. If you're in one, you can't be in the other. So we just get to add these values. So I add 10%, right? About 9% of the people surveyed smoked. So that's 4.2 and phasing, because we will be dealing with what we call conditional probability. It will really get you to think. So see you in 2 days.
Wednesday, not Thursday.
Did I say Thursday?